So in this question, we're told that figure 1, this graph here, is a graph showing the trajectory of a rugby ball. The height of the ball above the ground h meters, which is the y-axis here, has been plotted against a horizontal distance x meters, the x-axis here, measured from where the ball was kicked, which is the origin here. And the ball travels in a vertical plane, which tells us that this is just a two-dimensional problem. Now it goes on to say that the ball reaches a maximum height of 12 meters and hits the ground at a point 40 meters from where it was kicked. And we need to find a quadratic equation linking h with x in both situation. Well, first let's use this information here to plot the points of the graph. Well, we know the maximum height is 12, which is at this point here. That's the turning point of the quadratic, so that's 12. We know that this is 40, as that's where it lands. Now, because we also know that quadratics are symmetrical, we know at this point here, where its maximum height must be 20. So now that we know all of that, we can go on to find a quadratic. Now we know the quadratic is going to be in the form of h equals ax squared plus bx plus c. And then we just need to find out what a, b, and c are. Well, we know 3 points along this quadratic. There's 0, 0, where it starts. It's 20, 12, the maximum height of the ball. And there's also 40, 0, where the ball ends up. So first, let's plug in 0, 0 into this quadratic and see what we end up with. Well, h is 0. Then we'll have a, 0 squared, plus b times 0 for x's, plus c. Well, we know that a and b both cancel out, because that's both 0. So left with c equals 0. Okay, now let's use the next point here, 20, 12, and see what we get. So, when h is 12, x is 20, which is going to be a times 20 squared, plus b times 20. And we have to write plus c because we know plus c is 0. Now simplifying this, we get 12 equals 20 squared, which is 400, 400a, plus 20b. Well, we can't directly solve this as we have two unknowns in one equation. So let's use our final point here and plug into here and see what we end up with. So, h is 0 here, x is 40, so we have a times 40 squared, we have b times 40, and then we know it's plus c because it's 0. Simplifying this, we have 40 squared, 1,600, a plus 40b. And now we can solve for a using this equation, plug into here, and then solve for b as well. And then plug it back into a and find out what a is. So, 1,600a equals minus 40b, just taking away 40b here. Then divide by 1,600 leaves us with minus 1 over 40b. Now I can plug that into this first equation here. It's left with 12 equals 400 times minus 1 over 40b plus 20b. Simplifying, we have 12 equals 400 times minus 1 over 40, which gives us minus 10b plus 20b. So 12 equals 10b. And finally, that means that we know that b equals 1.2. From here, we can find out that a equals minus 1 over 40 times 1.2, which leaves us with minus 0.03. So finally, our answer will be h equals a minus 0.03x squared plus b 1.2x. However, we can still simplify this further by factorizing out the x. So really we can write this as x times minus 0.03x plus 1.2. That right there is our final answer. In terms of the marking for this question, we get 1 mark finding the final answer, we get 1 mark finding out what b is, and we get 1 mark finding what a is. And that right there is a total of 3 marks. Now that we're done part A, we can move on to part B. So in part B, it tells us the ball passes over a horizontal bar of a set of rugby posts that's perpendicular to the path of the ball. And the bar is 3 meters above the ground. Use your equation to find out the greatest horizontal distance of the bar from O. So what this question is basically telling us, sort of in disguise, is greatest horizontal distance from the bar from O is just known as x, and bar is 3 meters above the ground is just RH. So what this question is really saying is we need to find out what x is when h is 3. Now going back to a quadratic, we have h, which equals minus 0.03 x squared plus 1.2x. And we need to find out what x is when h is 3. So when h is 3, we get minus 0.03x squared plus 1.2x. Now I'm going to add 0.03x squared and take away 1.2x, get everything on the same side. So now we're left with 0.03x squared minus 1.2x plus 3 equals 0. And now we're left with a quadratic that we can try and solve. So first thing I'm going to do is simplify the quadratic. So 0.03 as a fraction can be written as 3 over 100. So what I'm going to do is I'm going to times everything here by 100 and then divide it by 3 to get the x coefficient as 0. So x squared minus, now 1.2 times 100 divided by 3 gives me 40, so I have minus 40x. Now 3 times 100 divided by 3 will give me 100. That equals plus 100 equals 0. Now I've just done this to simplify the quadratic. Now what I can do next is complete the square on this quadratic. So x minus 20 squared, and what I've done here is half the 40, and then so I've got minus 20 in there, minus 20 squared plus 100 equals 0. Bringing the 20 squared and the 100 to the other side gives me the x minus 20 squared equals 20 squared minus 100 on the right hand side, which leaves me with 300. Taking the square root of x minus 20 equals plus or minus square root of 300. Finally, I'm left with x equals 20 plus or minus square root of 300. But which solution do I choose here? Well, it says in the question that we need to find out the greatest horizontal distance from the bar from O. And 20 plus 300 is greater than 20 minus 300. Therefore, we know that our solution is going to be x equals 20 plus the square root of 300. And in meters, this will give us, using a calculator, like 20 plus square root of 300 will give us 37.3 meters to 1 decimal place. And that's it for this question. In terms of the marking, you'll get 1 mark for getting the correct answer. You'll get 1 mark for finding the solution, 2 solutions for x's, and you'll get 1 mark for forming the quadratic here, for a total of 3 marks for this question. For the last part of the question, we need just to give one limitation of the model. And the simplest one to give is that there is no modeling of air resistance on the ball. And in reality, air resistance will act on the ball, decreasing the distance that will travel both vertically and horizontally. Now answer will give you the 1 mark you need for the question.